stop sharing your screen real quick and then
yeah,
share it.
Yep.
Sweet. Okay, we are live. So we'll just give it a few minutes, let some people join in here. Let me share this around.
And then should I be watching the YouTube too, probably, just so I can see?
I think at the end, what I can do is just any good questions in there. If you also want to like peek while you're doing, you can. But if anything, I'll just drop good questions for you.
Yeah, I'll watch too, just because I want these sessions to be pretty collaborative. I want them to be less lecture-y. Because I also don't even have I don't even have a half hour of content. I don't even have an hour of content. So I really want to use this time to kind of, talk about building DeFi protocols and how to build them. And I guess I'm introing right now. Oh, we're not recording. Oh, we are live on YouTube though.
Okay. Yeah, we are live. Cool. Well, welcome everyone. Thanks for joining us. We'll get started here in just a few minutes. Let some more people join.
How's everybody doing?
Yeah. As Patrick was just saying, if you're just joining, we really want to make these collaborative. So we'll keep an eye on the YouTube page. Definitely any questions that you have, drop them into the chat. I'll be collecting those as we go along. Hey, Don. Yeah, thanks a lot for joining.
What's going down?
We'll just give it just like one more minute. How long would you say it is? About like 30 minutes or so?
It's honestly, it can be as long as we want it to be.
Cool. Sweet. Well, we can go ahead and get started. Thanks everyone who's joining us on YouTube. Really excited for Patrick to be joining us, giving us a presentation about building DeFi protocols and preventing price oracle attacks. So these have been happening quite a lot lately in the DeFi realm, and there's a lot of ways to prevent these. And so this is what we kind of want to go into. You'll also notice this is our first Chainlink Builders session. So we'll be doing a lot more of these more often. If you have topics that you're dying to learn more about within Chainlink development, definitely reach out to myself or Patrick, and we can help kind of get a workshop about that going and get you on the right track. As always, our doors are always open too. So you'll find us on the Chainlink Discord, which will drop all the links in. Feel free to reach out to us if you have questions about anything developer related anytime, and we're available. Without further ado, Patrick, thanks a lot for joining today and for hosting this.
Yeah, Keenan, thank you so much for setting this up and having me here. Excited to chat a little bit more here. So for those in the chat, so I'm watching the YouTube chat here. Definitely want to have this be a little bit more collaborative session. So if you have any questions, feel free to reach out. How many engineers are actually watching right now? How many engineers are here? Looks like there's a little bit of a delay. Not very many. All right, cool. Well, I'm just going to go ahead and share screen and jump right into it. So we're going to take a look at some of the past attacks and what the tools are that they have been using, and then we can kind of use this knowledge, obviously, to build our DeFi protocols moving forward in a secure, reliable way, right? So history repeats itself, and we want to do our best to make it not repeat itself. So in front of me, I have preventflashloanattacks.com. It's got some of the most recent attacks and the transactions. We can actually look at the transactions of some of these attacks and see exactly what happened. For example, I forget which one this is, but does Etherscan say what it is? November 14th. What happened November 14th? So this is probably Value DeFi. Oh, Value DeFi or Cheese Bag. But we can see this massive list of transactions, super complicated transactions, to find these really tiny holes in the code. And, the attacker just used it to just, destroy and blow these holes wide open. So a lot of them start with flash loans, with taking out crazy amounts of leverage, to basically, be able to do these a lot cheaper, right? This person did this insane transaction and it cost, $75. So, so you can check out that website. You can go check out some of these attacks and what actually happened. But we want to talk about what's actually going on here. So let's look at one of the simpler ones. I forget which one was the simpler one. So that one's reentrancy. Actually, they're all pretty tricky. They all have a lot of stuff. Yeah. Anyways, so generally what we've seen from these attacks is one of two different kinds. We'll see this Oracle attack and we'll see these reentrancy attacks. And then we're actually going to look at building a quick DeFi protocol and building it to get owned and then building it to actually be good. So these, the Oracle attack, reentrancy attacks, and then there's one other kind of type of attack. It's like pump and arbitrage or like economic attacks. These ones are a little bit harder to quantify. They're a little bit harder to decide if it's right or not, and we'll talk about that in a second. But yeah, let's go ahead and let's build a DeFi protocol and learn how to make it right and learn how to make it wrong. So we have some code here, and again, this is going to be a little bit more technical. Please feel free to reach out, ask questions as we're going along here. What is this one? Oh, that's the same thing. Please feel free to reach out and ask questions here as we go along. So what this is it's code for a call, a really simple options protocol, really simple options protocol. So if you wanted to make a DeFi protocol that does some type of options trading, you can check this out. We actually wrote a blog on this, how to build a DeFi call option exchange and Solidity. Code and kind of everything explainer is in here. We're just going to jump right into it, kind of do a real quick brief of it. Basically what we're doing is, what do we have? We can write options. So we can write like a strike price. We can write, hey, we want to sell or buy a token X number of days for this much premium, and it's going to expire in a few days. So we say, hey, for those of you who are a little bit unfamiliar with how options work, basically you can say, I want to buy or sell. I want the right to buy or sell an asset before some time. Right, so that's what an option is. So in cryptocurrency, it's literally as simple as, hey, I want to buy or sell, Ethereum or an ERC20 in a week, but at like this price. And there's a lot of reasons why somebody would do it. One of the reasons is for premiums. You can charge like a premiums on writing these. So we can write these options. We can also buy these options. So when somebody writes it, you say, hey, I have 100 USDT. I am willing to write an option. Somebody pays me $5 for squeezing you to buy it at 90 USDT or something like that. Somebody can buy it and then somebody can exercise it. So these call options here, you have the right, but you don't have to, but not the obligation to exercise these. So then we also have this exercise function. And so this is kind of the basic smart contract that we're going to go here. Again, all the comments are in here. Oh, hello. We have a question. When will the storage option come? What does that mean? I don't know what that means. When will the storage option come? Yeah, let me know what that. Yeah, let me know what that question means. Anyways, so we have this options contract, and getting the price of these assets is really, really important. All right, because if we're going to say, hey, we want to set the strike price, we want to say you're allowed to execute this option when the price is $100. If we have the wrong price, we're going to get screwed. And we can see that's what actually happened for a lot of these protocols. What will happen is these protocols, they'll have their price depend on one of these a decentralized exchange, like Uniswap, like DYDX. I know a lot of these. I know a lot of these exchanges are doing taking a lot of preventative measures to kind of mitigate against this. But at the end of the day, they're decentralized exchanges, but they're not decentralized price feeds. They're not decentralized data feeds. They're still single points of data. The data depends on their liquidity. So like Uniswap, for example, Uniswap works when there's money on either side of the pool. So if you have 1 ETH on one side and 100 USDT on the other side, that 1 ETH is worth 100 USDT and vice versa. But it all depends on the liquidity. So if you dump it, a million USDT on one side, the ETH is now worth a million USDT. Flash loans allow you to do that for a very short amount of time, for one block in particular. So if we look at our smart contract here, it's really easy to find where some of these Oracle vulnerabilities are, or these Oracle manipulations are, by literally just looking for, okay, where are we getting that price from, right? So our application here is going to be really simple. Since we just have our write options, our buy options, and our write options say, what's the strike price, right? And then what's the premium, whatever. When we look at the strike price, we can kind of do almost like a self audit and say, okay, we're getting the latest cost to be the strike price times the amount of tokens, and we're dividing it by the ETH price. This is how we're getting the value. So we can do a quick, like almost backtrace, say, okay, cool, where are we getting this ETH price from? ETH price is what? It's a variable. It's like a global variable here, and we actually set it. I believe we call like update ETH price. Where is that? We have this update prices function where we set the ETH price to this get ETH price function. So, okay, cool. Let's go to this get ETH price. We can go back to this function. We can see where we're getting the data from. Okay, cool. So obviously, you should be familiar with this if you're here. If you're not, that's fine too. So this is the syntax for getting from a Chainlink price feed. So we have ETH feed dot latest round data. ETH feed is a Chainlink aggregator contract at this address. So this is on the Coven network. So we can actually go to the Chainlink docs. Go to content addresses, and we can see, oh, excuse me, wrong one. Contract addresses on Ethereum. We see this is the ETH USD price here. We can click it. It'll bring us to the contract itself. These are not the transactions. The transactions, I believe, are back here, or excuse me, no, sorry, this is the proxy. It's going to be in the aggregator. Don't worry about that for now. If you're confused about the aggregator versus the proxy, we can talk about that in a second. But we can look at the DeFi price feeds, and we can see that we're getting our pricing data from all these nodes. And it looks like we just hit a heartbeat, so that they're all responding right now. So all these nodes are where oh wait, no, it just took a second to load. All these nodes are where we're getting our data from. So we're getting our data on the price of ETHUSD from this network of decentralized nodes. And why is this important? This is really important because back in our contract, if we had this get ETH price function be, something like dex.get latest price of USD or whatever the syntax for the function is, this is going to return the price on that DEX, on that decentralized exchange. And again, if someone does a flash loan, if someone crashes it during that single block, your smart contract is now jeopardized because somebody can easily flash crash that exchange, ruin your smart contract. And if you were setting the let's say, if somebody wrote an options contract for some crazy insane amount, now they can just flash crash the exchange and just make out like bandits, basically. So this is the easiest. This should be the easiest way to protect yourself against these flash loan attacks, is using decentralized prices, using Chainlink price feeds, using this network of decentralized oracles to get these price feeds. Now, if there's a data feed that isn't here, feel free to reach out and suggest something. You can also build your own price feeds as well. You just go to docs.chain.link. You can go to using an API and then just use a network of nodes to get a network of APIs to kind of aggregate your own decentralized answer on the price feed. So this is the easiest way to prevent some of these Oracle attacks, is using these decentralized price feeds. Because again, they can't be flash loan attacked, they can't be flash hacked. So that being said, I kind of know I bounce all over the place and talked a lot. Are there any questions so far? I think regulation will call for more use of decentralized oracles. Too much money stolen unnecessary, and for what? Erica, I think you're spot on. I don't know if, well, okay, regulation though, I think because this is the DeFi world, this is the decentralized world, regulation is kind of tough to say it will be implemented. I think standards will be built as opposed to regulations, right? And then it just becomes easy. Hey, anytime a new DeFi protocol comes out, you ask the simple question, hey, are you following these standards? If they're not, then you don't put money in. Then and hopefully auditors will pick up on the standards too, and they will have they'll have some insight to say, hey, don't do this. So I don't think it's regulators so much, but I do think standards will eventually come out, and getting pricing data will just be from decentralized oracles, because we've seen all these projects that don't get hacked because they're doing it because they're getting their data from decentralized oracles. Aave, Synthetics, Yearn, all these projects are using decentralized oracles, which have proven to be the superior way to get your pricing data. So good question. Yeah, standards. Yep. Yeah, but that's a really good point, though. That's a really good thought. I think regulation will call for more, or excuse me, I just read that. Is it fair to say that the release of staking is as much a timing issue as it is a development issue? It's a little bit out of scope for this demo. So yeah, out of scope for this demo. If you want to talk about DeFi, if you want to talk about flash loan attacks and prevention, you're in the right spot. Yeah, staking. If you want to talk about staking, you jump into the Discord. Anyways, where was I? Yeah, so let's take a look at this. Let's compile. Let's deploy it. Thanks to Gage, he actually built this. Can you guys see that? I don't think you can see that. Cool. Oh, actually not cool, but you guys can't see my MetaMask, right? That's kind of.
Yeah, I can see it.
You can or you can't?
Yeah, when it's there. Yeah.
Okay. All right. Well, I'm going to deploy this. Oh, this is rank B. Whoops. Sorry. Need to go to Coven. Apologies. Oh, okay, cool. Yeah, you can't see it. The stream is really delayed. Let's compile this guy. Deploy. I meant to do this. Now we'll deploy to Coven. While I'm deploying, any other thoughts on flash loans, staying safe, decentralized oracles? I feel that a lot of people in the chat here are pretty based, so I might not need to get educated on the power of decentralized oracles, and I could probably move to the next topic. Anyway, so yeah, so we have we just deployed our smart contract here. We have all these options here, and again, these are going to be where we're getting our price. So anytime I would, if I wanted to write an option, I would write the token string. This would be like the address of token. Option. Strike price. That's going to be a unit, obviously, and then yeah, the rest of the parameters are in here, and then we'd have a list. Actually, yeah, I can't just do the. I was thinking for a second. Link Coven address. Let's go ahead and let's just do it. Let's do it live. Address of the token. We're going to say the strike price is going to be 15. Premium is going to be 1. Actually, I think this is in way, so it's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And the expiry, I believe, expiry is in seconds. Let's say this is a 60-second contract for 10 tokens. Let's write this option. Error encoding argument, it's invalid params. What is my invalid param here? Oh, I need a quote there. Gas estimation failed. Why is gas estimation failed? Token hash equals eth hash. Token hash equals link hash. Only eth and link are supported. Token. Give me a second, sorry. Oh, right, duh. Sorry. Oh, still failed? What did I do wrong? Link, strike, expiry, token. Is there no quotes? Anyone see what I'm doing wrong here? Oh, I think I need to do the. That's right. Oh, wait, no, I don't, because I'm doing a link. Sorry, guys. I did this earlier. Do I just need to do F? Estimation failed. Incorrect amount of link. I have fake ETH, right? All right. Well, I forget what I'm missing here. I could probably go back and figure it out. But yeah, if you guys want to figure it out, it's all on the blog here too. I would just have to go read it in front of you guys, and I don't really know if I want to do that. But basically, what I was looking to demo here, anyways, is if we're getting the prices from here and we do a flash loan, it's not going to get affected, and we're going to be safe here. So that's the simplest one to look at. That's the easiest one to look at. So some of the harder ones are going to be these reentry attacks and these pump and arbitrage. So reentry attacks are really tricky. And luckily, recently, a lot of work has been done to kind of mitigate these and fix these. A reentrancy attack is when you have a contract, and then let's say even just write it one. Let's actually keep some of the boilerplate here. It's going to be a little bit pseudocode here, guys. When you write a contract, actually, let's keep a function too. When you write a reentrancy attacks are when you write a function that calls another external function, and that external smart contract recalls or re-enters your contract before that function completes. So you can think about this like asynchronously a little bit. So let's say this is our function called reentrance, and it's going to do we have like a map of, or we have like a balance equals 10, right? And that's actually, let's call this withdraw, right? So this this function is going to withdraw. What it's going to do, it's going to do like token transfer or call to message.sender. And let's say this is some token we don't understand. It's going to call this transfer function to this token contract that we don't know. And now we're going to do balance equals 0. So really simple function, and it's just withdrawing our balance. The issue is really, really subtle, and it's actually with this line right here. So using the transfer function makes it a little bit safer, actually a lot safer. But what can happen is we're calling this external contract that we don't control, and we don't know what that contract is going to do. So let's say that contract actually calls our withdraw function again, or excuse me, it's going to do token transfer message.sender balance. Let's say that this contract, this token contract, recalls our withdraw function. So what's it's going to do? It's going to do token transfer message.sender balance again. Balance is still 10. Balance hasn't updated to be 0 yet. So if we keep calling this, it's going to be very recursive, and it's going to keep recursively calling this withdraw function until the balance basically until there's nothing else, until there's nothing more. And then after all these function calls return, they're all going to update to 0, and you're going to be drained of whatever token was in here. So these are called reentrancy attacks. They're also called recursive attacks. They're the type of attacks that hit the DAO. They've been hitting a lot recently. These are a little bit trickier to find because you kind of have to you have to look through the code and see where some of these vulnerabilities are. Hopefully auditors are going to get better at this stuff. An easy way to fix this is just this. It seems really simple, but that's it. If we move the balance up to be updated to 0 first, then when we do the token.transfer, we're not going to do it with balance anymore. We're going to do it with like token amount or something. Equals balance. Token amount equals balance. Then we reset the balance equals 0. Message.sender token amount. Right, and this is a little bit inefficient, right? Because we're setting it to another variable, but it's a really easy way to have this be a lot safer, because we're going to call this function, or excuse me, we're going to run this line. We're going to run this line, and now balance is 0, but we still have token amount. And if this transfer function, if this token contract recalls or withdraw, well, balance has already been set to 0, so this is just going to be 0. So they're actually just going to end up wasting a ton of gas for themselves. So really simple fixes, but they can save you a ton. They can absolutely save you a ton. So the last one that I briefly want to talk about is these pump and arbitrage. these kind of like economy attacks. These ones are a lot trickier to find. You have to be a lot more economically savvy, and they're also some people will argue that they are fine and that they're not actually attacks, that they are just the way the protocol was designed to behave. So a really simple example of kind of how this would work is you kind of do the same thing, but it just, instead of manipulating the price, manipulating oracles, you just manipulate the price. If you have like a decentralized protocol where it all depends on liquidity, you dump a bunch of liquidity in one side, it can ruin the price on the other side, and boom, you now have this arbitrage opportunity. So you're not actually manipulating the oracles, you're manipulating the liquidity and the pools themselves, and you're pumping and you build these artificial arbitrage opportunities. And some people, like I said, some people argue that these are fine. These are how the protocols were designed to be. And so they're a little bit trickier and they're harder to find. But those are kind of the three types of attacks we've seen. Obviously, the Oracle attacks are super easy to fix. Just use the decentralized price feeds. Using your price feed from the decentralized exchange that you're working on is not going to protect you at all. Thank you for digging the fall vibes. Appreciate it. But yeah, using the price of the decentralized exchange isn't a defense against these attacks, because again, all these attacks we've seen, they're using dexes, which dexes are great. We all use dexes, and dexes are great for what they are. They're these wonderful decentralized exchanges, but using them as your price feeds is going to hurt you. Using them as your price feeds is going to end up like some of these guys. So just kind of heed the warning, right? Don't do this. Don't use, if you find yourself ever getting a price, or ever getting any type of data, right? Just think to yourself, okay, where am I getting this from? Is it from a single point? If it's from a DEX, the answer is yes. You should probably swap it to Chainlink decentralized price feeds or Chainlink decentralized Oracle. So that's all I wanted to touch on, because again, we've seen a lot of these attacks happening recently, and luckily a lot of those in the Chainlink community have been fine. Again, because they're using these price feeds, they're using these decentralized price feeds. But we as a DeFi community, we can't let this happen, because we'll drive less adoption to DeFi in general, and we want people to be safe, reliable, and secure. So yeah, that's pretty much all I wanted to touch on. Apologies, I wasn't being competent with the call options smart contract. But yeah, go check out that blog. It'll show you how to do it. Show you how to build your first DeFi protocol. We also have a ton of build DeFi project. We've also been putting up more articles on building your own DeFi apps. So we have this one on building out your yield farming DEP using Chainlink price feeds. It's really fantastic. A lot of people have been using it as a basis for a lot of their hackathon projects, which is great because it has a really clean interface inspired by DApp University. So thank him for that. So yeah, with that, just wanted to go over that. Are there any questions, any thoughts? Anybody feel like they're still vulnerable to attacks? And I know I'm a little bit delayed on the stream here, so I'll wait a quick minute for the stream to catch up to me. And if there's no questions, I'm happy to jump off a little early here. But yeah, if you guys have questions about anything, I guess we can probably branch off of branch off of DeFi flash loan attacks, we can go into how to build something if you're questioning about building something or anything of the sort. Yeah, feel free to let us know.
Cool. Yeah. Thanks, Patrick. So you mentioned the blog with creating your own DeFi application. I believe it's a farming one, right? If someone's just getting started as like a developer, do you have like other like resources that you recommend they check out?
Yeah, for sure, actually. And thanks guys for tuning in. For sure. So, why is this saved? That's weird. So there's a ton of them actually. So if you look up, are we talking like Solidity in general or DeFi?
Yeah. I'd say both if you can go through both.
Yeah. So honestly, if you just type in learn Solidity, you're gonna get a ton of courses. I actually I learned from a combination of sources when I first was learning Solidity. I took a Udemy class, which I thought was really good. And I watched a lot of YouTube. I read a lot of guides, just kind of like anytime I wanted to learn, like after I took kind of the basic course, I bounced around. Dapp University is a great place. He's got great videos. His tutorials, his YouTube videos, I think are the most thorough, and anybody from any kind of walk can kind of jump in and understand what he's doing. So they're very good. Solidity docs are very good. Crypto Zombies is also a great place. So I would say those three places: Udemy, Dapp University, Crypto Zombies. We're working on trying to help other educators in the Solidity space as well. So hopefully we'll have more answers for you on that too. And then you said DeFi protocols too. I don't think there's any courses for purely DeFi protocols. I think if you learn how to code Solidity, and then you do a little bit of a brushing up on your financial terminology, because all DeFi really is it's just the same financial tools, just in this new space. I think that'll be really good. Obviously, they're this new paradigm, right? Because there's no company, there's no they're run by these engineers. A lot of them are run by DAOs. But if you take a lot of the terminology and a lot of the core concepts from traditional finance to DeFi, it's going to be exactly the same.
Cool. Yeah. Thanks for sharing. And again, everyone who's tuning in, if you have questions, definitely drop them into the chat, whether related to this or other development related things that you're working on. Now's a perfect time to get some feedback.
Maybe we'll make maybe we'll do another one of these, and it'll be, well, obviously we're going to do another one of these, but maybe the next one of these we'll make it a little bit more, maybe we'll make it like interactive. Maybe like as a group, we'll build something. Maybe that will be fun.
Yeah, I think that'd be really cool.
Yeah, we figure it out. Cool. Well, if that's it, I think we're all set here.
Cool. Well, yeah, thanks a lot, everyone, for tuning in. Again, join the Chainlink Discord, ask questions within the Chainlink Discord. As mentioned yesterday, for developers, there's going to be some new cool things coming out, so keep an eye out. And yeah, definitely, stay active and check out the Chainlink docs too. There's some cool hidden features. So if you're just learning Solidity, go through them, try them out. And walk through as well.
So actually, just real quick, saw Eric say build an NFT using VRF. I actually just did this the other day. Eric, are you an engineer? Like if Keenan, if you're game, I'm happy to do this like right now.
Yeah.
Okay. Eric, you an engineer? You are you looking to build an NFT using VRF? Oh, this delay it makes it actually tricky to to talk with anybody in the chat. I feel like I'm like watching myself. I think I like just said it. Oh yeah, maybe I should. I am an engineer. I am an engineer. Okay. All right. Yeah, sure. I'll show that actually, because I was just doing that. So we actually have an article on this too, building an NFT with Chainlink VRF. And I was literally just working on like a new version of that. Do it. I was curious on, yeah, I'm building a new version of doing that to make it a little bit, to make it viewable on OpenSea. And for those of you here, actually, I'm going to drop the hint to watch some of the blogs and docs closely. That's all I'm going to say on that. There's some interesting stuff coming up in the blogs and docs. But anyways, so here's like a really simple like code for making an NFT. I wonder if I can just, you guys want to see it from scratch probably, right? I'm going to use this as like my little cheat code that I'm going to refer back to. But yeah, sure. Let's do one from scratch. So let's call this NFT sample.sol. And then if we're good, hopefully we can build this in 20 minutes here. We'll call it random man. What are we going to call it? Oh, this delay sucks. Random person, random NFT. We're going to call it random contract. Random NFT is ERC VRF is ERC 721 VRF consumer base and ownable. So the first thing, in order to make our random NFT, we need to inherit kind of the base standard for the ERC 721. So this is the so Open Zeppelin has a ton of packages for building pretty much anything you want, and we're going to import from there. And you'll see why in a second. We also want to import the Chainlink VRF consumer base so we can interact with the VRF. We're also going to grab ownable and strings just because that's nice. Then we're going to do, I'm just going to flip for my cheatsies here. Yeah, we'll do constructor public, because every NFT starts with, or every contract starts with a constructor, and with NFTs, since we're inheriting this ERC 721, we give it a name and a symbol. So let's call this random NFT, and we're going to call it RNFT. So the symbol is going to be this and this. And we also need to, since we're also importing the VRF consumer base, we need to give the piece of the VRF consumer base here. Hold on, let's go back. I'm just going to grab, we're going to cheat. I'm going to grab it from my little past code here. VRF coordinator, link token. And we need these for the VRF. So cool. So we have a constructor. We have the VRF consumer base. We have the ERC 721. This means that our NFT is going to be called random NFT, symbol RNFT, and we need this to interact with the VRF consumer, and we'll see that in a second. So cool. I'm actually just going to copy this because this is the main function. So now what we need to do is we need to make a function to kind of like get the random attributes for our NFT. And we can kind of do whatever we want here. So let's say we want just something really simple. We want to we want to give our NFT like a stat. We want to give it like we'll call it a uint 256 power or whatever your stat is. Excuse me. Sorry about that. Whatever our random number is, right? So we're going to say uint 256 power. We're going to do power equals 0. We're going to initialize the power equals 0, but we're going to give it a bigger number. So we're going to do function request new random NFT. We always need to give it a uint 256 seed. We'll give it a name. Oh, wait, no, we don't need to give it a name. That's it. We just need to give it a seed. Or actually, we're just going to call it request random stat. Yeah, we're going to call it request random stat. So we're going to give this random power. We're going to give our random NFT a random power stat, right? So we can do this quick require. And this requires that we actually have link to make the call. And then we're going to do, we're going to call this request randomness with the key hash fee and seed. And we're going to have to, the request randomness is, I think that one's, it's native, right? Like I don't need to define that. Yeah, I don't need to find it. So request randomness is a function that we're importing from the VRF consumer base, and we're going to send it a key hash and fee, which we need to define, which it's specific for each network. So we're going to do, we're just going to, sorry, I'm kind of ripping around because I have 10 minutes to do this. So key hash is going to be this, and the fee is going to be that. So every oracle is going to have their key hash that you need in order to interact with their Chainlink VRF. And the fee is obviously the amount of link that we're going to pay. So on the COVID network, which is what we're going to be doing here, because again, I've already done this before. I'm blanking because we're charging 0.1 link on the COVID network here. So this is all the stuff we need to get set up. And cool. So we're going to request this random number. And if I'm jumping around, feel free to jump in. Sorry, the delay here. That's kind of really annoying. We don't need to do any of that stuff. We don't need to do any of that stuff. So that's it. Boom. This is all the function needs to do. So what do we set up so far? And I don't need any of this because that's actually, we're going to make this a lot simpler. So we have our contract here. We have our NFT contract. It's a super simple NFT. We also don't need this. It's a super simple NFT contract. Once we deploy it, we're giving it a name right away in our constructor. We're calling it random NFT, and it's going to be our NFT. And let's even test it out. Let's make a quick script. Make a quick script. Oh shit, I should be on a different git checkout. What is this? What are we doing? Builders session. Cool. This way I don't screw up any of my progress that I was doing before. New file. We're going to call it deploy rnft.js. And I'm just copying, pasting from one of my other scripts here. I pretty much never start from scratch on any project moving forward because that's silly. Like, why would I ever do that? We're going to const, we're going to import, this should be capitalized, but it's fine. Actually, yeah, let's capitalize this. Rename NFT sample. Actually, what did I call it here? Random NFT. Random NFT. That's all. Get the naming conventions down. Let's check it. Truffle compile. Compile. See if it even compiles. Would I have 10 minutes to do this? I think I can do it. Oh, I have an issue. It's probably. expected. Oh, what did I do wrong? Constructor, public. I think that's what I did wrong. Let's try again. I don't think my other contracts are going to compile either, actually, because I was messing with them. If they don't compile, I'll just delete them. Users. Another issue here. What's the issue here? That needs a semicolon. What else? Yeah, okay. And then now, well, no visibility specified. Did you intend to add public? Yes, I did. Public. All right, cool. I think that should be good. And then we can delete all these. I'm on a different branch, so it's fine. Migrations. Great. Great. Patrick, build a brand new random NFT from scratch. Yeah, I can do that. Hell yeah. In 10 minutes. What is wrong now? Type error. Contract random NFT should be marked as abstract. Why? Relevant source parts spans across multiple lines. Missing implementation. Fulfill random. Whoops. Okay. Yep. Okay, cool. So actually, we're in a good spot. So we need fulfill randomness. So request randomness is imported by this once we inherit it here. So we also need to define our function fulfill randomness because it's NFT airdrops are on the Coven network, sure. So we need to bytes 32 request ID UN 256 randomness public. I think we actually do need to. Oh no, I just deleted everything, didn't I? Well, I think we need to make this not public. Sorry, I'm just checking a different branch. Dragons character. Fill. Internal override. That's right. Needs to be internal override. And this is important so that we can stay safe. Now we can do whatever we want here. So what we're going to do is we're going to take this power thing and we're going to have it equal to randomness. And this is what gets returned from our Chainlink VRF. And we're going to mod it by 100. So it should be between 0 and 99. We should get a power number between 0 and 99. And then what we can do is we're going to safe mint. Request to sender, request ID. Oh, no, we're not going to do that. Sorry. We're going to do that in the constructor. We want to safe mint the NFT. This is a function also imported by the ERC 721. I have 5 minutes here, huh? And this actually mints the NFT. So safe mint. This, we can find out what these are in the Open Zeppelin docs. I believe this is going to be the token ID, which we're just going to keep it simple, and we're going to have it be 0. And request to sender, and then this is going to just be message.sender. So we're going to say the owner of this NFT is the sender, and the token ID, or the NFT ID is going to be 0. So it's going to be the only one. It's going to be the only one. I believe I'm doing that right. So cool. Now if I run truffle compile, see if it works. Doesn't work. Did you mean randomness? Yeah, I did. Thank you. Welcome to doing it live. And another issue. What's the issue? Function has override specified, but it does not override anything. Am I spelling fulfill randomness wrong? I am. This should be lowercase. Cool, and we finally compiled. Yay. So now let's try to deploy it. I think we're like pretty much good. Is this it? Is this all we need to get a random NFT? I think this is it. So now let's do a quick deploy our NFT. So we're going to call this random NFT. Is that what I called this? An NFT, yep. Let's just close all this stuff. Equals require. So we're going to grab the artifact here. Module.exports async callback constant d equals. We're going to await our NFT.deployed. Does that deploy it? I think that deploys it. I forget. Get character. No. Update character. No. Yeah, I think that deploys it. Wait. Random NFT.deployed. Console.log. Let's say deploying our NFT to NFT. And we'll get the address of the NFT. Await NFT. Deployed. I think we need to give it. Constructor takes nothing. Right, we're calling it this. Cool. And now we need to do this request random power function. Request random power, and we'll give it. That's the random seed. It doesn't take a second parameter. Callback. So cool. Let's try it. So we'll do. Do I have this in my migrations? Oh crap. I need to migrate first. Let's do. So we need to migrate first. Once we migrate, am I already out of time? Oh, I have 2 minutes left. Sorry, kind of going quickly here. So our migrations is what we're going to run first. Equals rink B. Oh shit, we're going to do it on. We're just going to ignore rink B for now. Ignore this. Await deploy to deploy random NFT. Let NFT equals await deployed. Console.log NFT.address. That should work. So cool. Let's try this. So now we'll do truffle. And what do I have for rink B? I only have rink B for networks. I got to add Coven here. Oops. Coven. Can I do it in like 1 more minute? 42. Full compile. truffle migrate dash dash reset dash dash network Coven. And this should deploy it to Coven. And then we should be able to run our script and pull a random number, and that'll be a random NFT in 15 minutes. So that's pretty crazy, unless I didn't do it. Random NFT is not defined. Okay. Okay, well that makes sense because I didn't import it. So let's import it. Let's try it now. I'm past time. I'm sorry, guys. I was too slow. Well, this is kind of fun anyways. We talked about DeFi and then we switched to random NFTs. I guess I was kind of itching to do this because I kind of just hopped on that, huh, Eric? Cool. And it's looks like we have our random NFT. Yeah, pretty much. It's pretty straightforward. So cool. We just deployed it. Now we'll fund it. Let's do this actually. Make it super easy for ourselves. Quick replace. We can get rid of this battle stuff because I'm not doing any of this battle stuff. We're gonna want to fund it, so do blah blah. I need this battles. Oh wait, battles that get. Oh wait. We're gonna fund it the old-fashioned way. I'm just gonna send it some link just because I don't feel like writing a funding script. If my MetaMask will work. Which it seems like it finally is. I know you guys can't see this, but I'm sending. Come on, MetaMask. Come on, buddy. Ay. Setting that address. 10 link. This should be enough to request a random power. So it's actually already deployed. So this is a bad name. We're going to rename this to request random. And cool. And it looks like my link is still going through. It looks like it just finished. So now we do truffle exec scripts request random network Coven. See if this works. This is wrong. It should be requesting randomness from this thing. And once it pulls this, we should be able to see the random power on Etherscan. I'm also going to verify the contract so we can read it on Etherscan a little bit easier. Going a little bit over, but we're doing something fun, so it's cool. Anybody? Yeah, so it's pretty straightforward. Once it actually deploys. NFT.request random power. No worries. This was kind of fun. Appreciate the ask. I'm just trying to see what was the why is this function taking so long? Require link to bounce. Not if link fill contract with faucet. Looks like it's stuck here on this request random power. Wonder if it maybe went through already. Let's find out. Let's go check out Etherscan. Yeah, it looks like that errored. Let's try it again. Show you what Etherscan's showing me. Boy. Etherscan is telling me, hey, I did something wrong. These are the last two that went in. They both failed. So that means I messed something up. It's the area. So we have some Chainlink in here, which is great. Token tractor, it's called random NFT or NFT. We can see that on Etherscan, which is kind of cool. But it looks like we messed something up. So it'll probably take me another couple minutes to triage it, but let me just take, and I know I'm super over. I'm just going to quickly look at the docs here to see if I messed something up. Oh, it's because it returns. Ooh. Yeah, so I'll have to recompile and redeploy after doing a couple of changes. But that's basically it. And yeah, you could have a random NFT that simple. Just fix the change the code so that it's not so that this function is actually correct. Well, but that's it. I know I ran a little bit over. We ended up doing something kind of fun in addition to learning how to protect ourselves against DeFi attacks. But yeah, that's it. If you guys have any other thoughts or questions or something that you want to see, let me know and be happy to demo. So awesome. Thanks, guys. Bye.